All right, Math 206, we're still working through section 11.3 on angles. This will be our first construction. All of chapter 12 will be about making, about constructing angles and images and things like that. So what we're doing here is constructing parallel lines. So first thing, assume that you're given one line. So just draw a line anywhere on your paper. We'll call that line M. Now what we'll do is take your ruler, which will act as a transversal, and you put it anywhere so that it's intersecting your line. And suppose I want to draw a line that's parallel to M through some other point, P. Let's just draw any point up here and label it P. So what I want to do is draw a line that's parallel to the line M through P. Now, one thing that I know we tend to do is just wing it by sight. So what I've seen people do is you take this line and just kind of push it up and say, it looks like it's probably parallel. But that's not a very mathematical way to do this. So instead, take your line M, use your ruler as a transversal, and then I'll take a triangle that I've already pre-cut, and I'm going to put the triangle on my line, and then I will line up my transversal so that the transversal lines up with a side of my triangle, like so. Okay, so again, I've got my triangle that I cut out, so the edges are straight, so that the one side of my triangle is the line M, lines up with the line M. All right, now I'll take this triangle and I'll slide it up my transversal until that top side intersects with that point P. So now notice this angle hasn't changed, and this angle made by the transversal and the top of my triangle is the same as this angle down here, which is made by the top of my triangle and that transversal. So all I'm doing is copying this angle so that the top side of my triangle passes through that point P. So now I have sketched that side of the triangle, and I can use my ruler now to extend that line so it's a little bit longer. So you've just constructed a line L that's parallel to this line M. And the image for that is here. This is exactly what we've done down here with this construction. And what we see is that this angle, made by the angle of the triangle, BAC, is the same as this, or congruent to this angle up here, made by B prime, A prime, C prime. So because those corresponding angles are congruent here, you know that those lines have to be parallel. All right, so that's going to be our first construction. Now let's do a few exercises which uses these ideas. All right, the first theorem that we're going to need is the fact that the sum of the measures of the interior angles of a triangle is 180 degrees. So we'll use this theorem over and over, but the question is, why is that so? So let me draw a triangle here, and I'll label the angles, say A, B, and C. Now imagine that the base of the triangle lies on a line M, and imagine that the vertex of the triangle passes through another line, we'll call that line L, in such a way that M is parallel to L. Right. So if that is the case, then imagine you have these two parallel lines, and this side of your triangle right here can be thought of as part of a transversal that cuts through the lines M and L. So C is one of these interior angles made by the transversal in those two parallel lines. And the alternate interior angle to this angle C is right up here. So whatever angle this has to be exactly the same because the two lines are parallel. So alternate interior angles are congruent. So if that's angle C, this is also angle C. All right, similarly, let me ignore that green line for a minute. Now let me imagine lines L and N being parallel, and the other side of the triangle, I'll imagine that as another transversal that cuts through those parallel lines. Then this angle here, A, must be congruent to its alternate interior pair, which is right up here. So let me call this one I'll call C prime, and this one I'll call A prime. So here's a few things that we've just done. We said that we draw a line L parallel to the base of the triangle, which was line N. So we drew that parallel line. And then we say that angle C is congruent to angle C prime by alternate, I'm going to abbreviate that by ALT, interior, I'll abbreviate that by INT, by alternate interior angles. And also angle A is congruent to angle A prime by alternate interior angles. So now you see that A prime, B, and C prime all create a straight line segment. So angle A prime, angle B, and angle C prime create a straight line or a straight angle. And notice that that's line L. Therefore, the measure of angle A prime plus the measure of angle B plus the measure of angle C prime equals 180 degrees. But then up here I said that A prime is the same as A and C prime is the same as C. So therefore, the measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. So that's true for any triangle. The three angles in a triangle add up to 180. And this is the justification for why that's so. All right, so now let's use all this, these ideas and solve a problem. So if you've ever used a jack for, lifting something up like your car to change the tires, in the framework for a tire jack, the vertices of that jack, say A, B, C, D, is a parallelogram, meaning that opposite lines there are, the opposite sides of the parallelogram are parallel. So if angle ADC of this parallelogram has measure 50 degrees, we could figure out the measures of the other angles in this parallelogram. So let's do some work to figure out why this is so. So imagine first I'll have the point of view that DA and CB are parallel. And now I'll imagine that this line here, DC, is a transversal that cuts those parallel lines. So I'm just going to completely ignore angles 1, 2, and 4 over here, and I'm just going to focus my attention right here. By alternate interior angles, this is 50 degrees, so this one also has to be 50 degrees. And now because these two angles create a straight angle, 50 degrees plus whatever the measure of angle 3 is, these two have to add up to 180 degrees. So I know here that 3 would have to be 180 minus 50 degrees, or 130 degrees. So I know the measure of angle 3 now. Now let me go ahead and change my perspective so that I could figure out angles 1, 2, and 4 here. So now let me imagine that my two parallel lines are AB and DC here. I'll make them both green. And I'll imagine that BC is a transversal. So this angle 2 here is in the bottom left corner relative to its intersection point. So down here, the bottom left corner is 50 degrees. So angle 2 and this 50-degree angle here, these are in corresponding positions. Therefore, angle 2 has to be 50 degrees. By corresponding angles. There's other ways to justify it, but that's just one. All right, now let me change my perspective one more time. And again, imagine AB and DC being these parallel lines. And now I'll imagine DA here being the transversal that cuts through those two parallel lines. So I'm going to ignore everything that's happening over here. So angle 4 here is in the top right position from this intersection point. So if I go down the transversal and look at this intersection point, top right, it's also 50 degrees. So the measure of angle 4 has to be also 50 degrees. And this is by corresponding angles. Now last, let me find this measure of angle 1 here. Well, 4 and 1 are supplementary angles. So the measure of angle 1 should be 180 minus 50, or 130 degrees. And again, I can justify that by citing supplementary angles. All right,